דיברנו קודם קצת על מהירות, יש איזה מיתוס לא ברור שאומר שמהירות היא לא שם המשחק, אבל אנחנו כבר יודעים מלא מעט מחקרים ומציאות שיש קשר ישיר בין היפגעות למהירות, ובנושא הזה על ניהול המהירות ככלי לקידום בטיחות, I'm honored to invite to this podium Professor Oliver Carsten, Professor of Transport Safety in ITS. ITS is the Institute of Transport Studies. Yes, Institute of Transport Studies, which we here don't have the same place for doing such a wonderful thing that you're doing over there. This institute received royal recognition, correct me if I'm wrong, by winning the Queen's Anniversary Prize, right? Yep. So we are honored to have you here with us. Thank you very much, Professor Carsten.
So good afternoon, everybody. It's a pleasure and an honor to be invited here. I gather I'm following some very distinguished guests. I hope I can entertain you as much as they do. And I'd like to particularly say thank you to Tzipi Lotan for the invitation and to the Foundation for all that they do for road safety. So one of the themes this morning obviously has been speed, and I'm going to try a bit and broaden it out because I think the focus has been mainly so far on enforcement, and I'm going to talk about other ways in which we can encourage compliance, though I do have a bit about enforcement as well. So the topic I'm talking about is speed management, which is really about how you apply a top-down strategy to looking at how the whole area of speed and speed choice relates to road safety and how we can change policies in order to bring down the number of victims. I can speak louder. Usually I'm told I'm too loud. And why doesn't this go? Which one do I do? The green button here? No. Page down doesn't seem to do anything. I can try the... Yeah, there we go. Okay. Okay, so first of all, why do drivers speed? I mean, I'm not citing all the research, but these are three elements that come out very much from the research. So some drivers actually get pleasure in speed. There's a thrill element, and we can understand that. I mean, why do people go skiing and engage in thrill sports and so on? Then there's the competition with fellow drivers. That seems to be quite an element in Israeli driving from my brief observation. We like to get ahead of the person in the next lane. Actually, yesterday in the bus, there were two buses racing each other in adjacent lanes coming from Jerusalem to Tel Aviv. But also, of course, there's a rational element to it. We spend time in travel. That time, if we can't do other activities while driving, that costs us. So we want to get to our destination as quickly as possible so that we can work or be with our family or whatever. So we want to cut down our journey time. One interesting element here is that drivers tend to overestimate the savings that they get in journey time by speeding. There's been quite a lot of research about that. So, why focus on speed as a problem? This is what one huge review of the research found. This is from Rune Elvik and his work on the power model, and I'm coming back to that, but the relationship between speed and safety. So, what he concluded in the 2009 version was that speed remains a very important risk factor. It has a greater effect on the number of accidents and injury severity than almost all other known risk factors. Now, the only word I would question in that is almost. I think that's superfluous. As far as I'm concerned, it has a greater effect than any other known risk factor. It's almost impossible to have a crash without speed as a factor, and as I'll show you, it's very, very closely associated with the outcome of a crash with the severity. So this is the power model. What the power model in its various versions essentially says is that injuries in accidents change with the proportion of speed for a length of road squared, serious injuries with speed cubed, and fatalities with speed to the fourth power. So that means if the mean speed of traffic on a road goes up by 10%, then the fatalities go up by 40%. Small changes in speed have a very, very dramatic effect on risk. And this is about individual risk. So this is, you probably can't see the index there, but this is the relationship between free traveling speed on 60 kilometres an hour urban roads in Adelaide and the risk of involvement in serious crashes. And what you can see is that if you're going a little bit faster than the mean speed of traffic, than what everybody else is doing, then you're hugely overexposed to the risk of being involved in a crash. So the speeders are the ones that cause the problem. Steve Stradling calls them crash magnets. And this is about risk. So the middle line is the plotted line, the dotted lines are the 95% confidence intervals, and we get this relationship so that eventually, right at the top end of the graph, it's almost certain a fatality will result, and in the middle, this is impact speed for pedestrians, and this is based on in-depth studies. You can see that roughly at 45 miles an hour, a pedestrian has about a 50% chance of being killed in a crash. And this is for car seat front occupants. I mean, it is beyond the possibility of vehicle design to protect occupants in very high-speed crashes. There reaches a point where no amount of airbags, etc., is going to protect that individual because the vehicle is simply collapsing around them. So if you can see that somewhere around 70 miles an hour in a frontal crash, you almost have a 100% chance of being killed. And again, the 50% chance is around 50 miles an hour, 80 kilometers an hour. And here's the same graph for side crashes, simply because there's less space in the vehicle to protect the occupant, and there's less material to protect the occupant. We have a very, very high risk of a fatality in a side crash. And that is, of course, what makes intersection crashes, particularly intersection crashes on rural roads, so dangerous. Well, what happens? I just did a quick search and looked at the penalties and what's going on in Israel, and here I found a Supreme Court judge, Hanan Meltzer, who was paying $520 US, 1,800 shekels, and he was going 135 kilometers an hour in a 90 kilometer an hour zone. I think in the UK you'd probably go to prison for that. How does Israel do in road safety performance? And I guess I can't obviously judge every element, and comparing one country with another is quite difficult. One of the things that strikes me, by the way, and I guess I'd like to talk to people afterwards about what they feel, is Israel feels quite dangerous when you walk around, when you observe the traffic, and yet it doesn't seem to do that badly in the statistics. So the first thing that one might ask is, are any people missing from the statistics? The Netherlands recently found they were missing something like 20% of their fatalities from the database. So anyway, Israel is about 40–45% worse than the best performing country in terms of road deaths per million population. So that's compared with Sweden. Does everybody know what sunflower means? Sunflower is Sweden, UK, Netherlands, sun. Generally assumed to be or shown to be the best performing countries in the world in road safety, and there's a series of reports you can read about why they have done so well in the last 10, 15 years or so. This is the comparison, and again, it's actually almost exactly the same difference. It's 45% worse than Sweden and the UK in terms of road deaths per billion vehicle kilometers. So you may aspire to be among the best in the world, but you're quite a long way off from being equal in performance at the moment. There's quite a lot of catching up to do. And another place in which Israel was identified as having problems, and I think we've heard a bit about that from this morning's presentation, is that you have a very high proportion of pedestrian fatalities among your road victims. It's 1/3. So you're in a league in OECD, which is the advanced industrial countries, you're equal in performance to Korea, Japan, and Poland. Again, not a very good place to be. Poland is the worst performing country in Europe. So speed management. I mean, there's a huge literature on it, and I can't possibly, in the time that I have to speak, cover all the elements in speed management, so I'm not even going to try. But there's a lot of reports out there. OECD has a manual, guidance, and whatever. And it's the point I already made. It's a core element in road safety strategy. When I look at the Israeli road safety strategy, I think there was a page on speed, but it didn't even use the term speed management. It just talked about compliance, enforcement, and whatever. It did talk a little bit about speed limits, and it did say that the aim was to improve the number of drivers complying with the speed limit, but it didn't really talk about the tools, the wide range of tools that are available. So these are the tools. This is the list, and if I had the whole afternoon, I could go through those one by one. I'm not going to. But we start with things like functional road classification, basically identifying what the road is supposed to do, and then saying, well, how do you design that road, and how do you set the speed limits for that road? We have things like 30-kilometer-an-hour zones. My taxi driver from the airport, when I arrived in Israel, he went 90 kilometers an hour in a 30-kilometer-an-hour street. So that wasn't quite correct. We have self-explaining roads. I'm going to explain that a bit. We have tools for dealing with drivers, encouraging drivers to comply when you enter lower speed zones, transition zones, if you like. We have enforcement, and we've talked about that. We have campaigns, and we have intelligent transport systems. And I'm going to talk quite a lot in the second half of my talk about intelligent transport systems, and in particular about that funny set of letters, ISA, Intelligent Speed Assistance. So how do you set speed limits? What are appropriate speed limits? Well, the Vision Zero group, and Klaus Tingvall was the person who originated the idea that we should be able to survive, that no country should be killing people on the roads. The Vision Zero group proposed that we should be setting speed limits in such a way that road victims, road participants can't get either fatalities or serious injuries as the result of a crash. So what are appropriate speed limits? 30 kilometers an hour on urban roads where you can have conflicts between pedestrians and cars. That means 60 kilometer an hour speed limits and 50 kilometer an hour speed limits are way too high. 50 kilometers on roads with intersections and hence the possibility of side collisions. So that means really we're pretty much talking about rural roads now, not urban roads, or segregated urban roads where you can have intersection crashes. 70 kilometers an hour where there's no possibility of a side collision, but there is a risk of a head-on collision, and 100 kilometers an hour where you have a median barrier and hence virtually no risk of a head-on collision. And I think all those limits are quite a lot lower than the prevailing limits in Israel. But furthermore, we need clear road categories. We want drivers to understand the functional role of a road, and we want drivers to understand how fast they should drive on a particular piece of road without the fear of a speed camera or a police car or whatever. So the Dutch identify three major road categories: through roads for flow, distributor roads to connect those through roads with local roads, and finally access roads enabling direct access to properties on a road or street. And then each of those three is multiplied by urban and rural, so we get 6 categories in all. So we have urban through, urban distributor, urban access, and so on. And they go, as I said, they go on to argue that the road user should understand the function, should have expectations about the kind of traffic they're going to encounter. Will I meet a cyclist here? Will I meet a horse here? Or whatever. And this is called predictability. Road environment, road user behavior, support road user expectations through consistency and continuity of road design. And they have a set of lines, pictures, signs, and whatever specifications that delineate each type of road. And in the Netherlands, what they've done is systematically go and re-engineer, if you like, reverse engineer, because they're fitting it afterwards, roads to conform to this kind of principle. What do we use to ensure compliance? I was told today that you have, I think, less than a dozen operational speed cameras in Israel, something around that. Well, in the UK, we have 2,500 fixed speed cameras and 3,500 mobile cameras. So the dose response in the UK is dramatically larger than what you have in Israel. We issue 1.7 million speeding tickets a year. If you get 4 speeding tickets within 3 years, you lose your license. And very, very few motorists accumulate those 4. They're too afraid to do it. So after 2, typically, after 2 tickets, they start to get really careful about their behavior. But we also have a lot of campaigns. You probably have the same. So these are extraordinarily dramatic now in the UK, the Think campaign, and it's been shown to be effective. The public realizes the connection between speed and risk. It's not just a piece of theory. So this, the video, you can find them on the internet. This video is about somebody brushing his teeth in the morning and then seeing in the shaving mirror, in the bathroom mirror, the image of the victim that he killed in the crash. And the same with the picture on the left. So has it worked? Well, this is the number of vehicles violating the 30 mile an hour, the 50 kilometer an hour speed limit in free flow traffic conditions, only free flow conditions on the UK roads. So we used to have only, way back in 1995, we had under 40% of drivers complying with the speed limit. This is without cameras, we don't have cameras everywhere. And now we have 54%, so year on year we've had an improvement. There are some years where it went wrong. And what I've done in this graph, if I've tracked pedestrian fatalities against those numbers, and this is not a statistical test, but there's an extraordinary correlation between the two. Even when the numbers go wrong on compliance, the numbers go wrong on the fatalities. As you can see, the pattern is exactly the same. And this is France. You probably heard of Jacques Chirac, who was the Bibi Netanyahu of France. He was president. He looked across the channel to the UK and he found out that us dastardly Anglo-Saxons, les roast beef, as we're called in France, actually performed twice as well in traffic safety as France did. So roughly the same number of vehicles, roughly the same size population, but half the number of fatalities. And he did really two things. Well, actually, he did one thing. He stepped up enforcement. And he stepped up enforcement on speed and on alcohol. And this is the result. When the cameras were announced, then the fatalities start to come down, but at the same time, the speeds came down. And the yellow line is the mean speed of traffic on French roads. Again, very, very close correspondence between the two trends. So, what I'm going to move on to is technology. That's the area in which I do my personal research. We can use technology to make drivers afraid. We've heard about that. That's the speed camera. Drivers can use technology for their own ends, and that's what the mobile phone and distraction is all about. Or we can use technology, which I think is the most valuable use of technology, to support drivers in the driving task. And my time's up, but I'm going to carry on for a little bit. So this is intelligent speed assistance. It's essentially the speed bump in the car. We're giving the drivers the information. So how does it work? Navigation system based on GPS. We add to that the speed limit on the roads, and then we tell the drivers what the speed limit is, and finally we can actually link the vehicle control to that information. Sounds horrible, etc., etc. Is it really as horrible as that? Well, there's been a huge amount of research. You can go and find it all over Europe, and indeed all over the world, even in North America, though the US Congress never heard about that. And we did 2 large-scale trials in the UK, multiplied by urban and rural, so 4 in total, 2 areas, Leeds in the north, which is where I work, large metropolitan area, and this Leicestershire in the middle of the country, which is a much more rural area. So it was 79 drivers in total, and this is the kind of system we had. Drivers could override it, so it wasn't a fully closed system, but the drivers had to choose when they overrode it. They had to do a deliberate action. The rest of the time, they were speed limited. A lot of mileage, so a lot of data, a huge database. Mix of younger and older drivers, male, female. Speed intenders are people who like speeding. Speed non-intenders are people who say they comply with the speed limits. And these are the results. So in the bluey color, you have the speeds before. In the purple color, you have the speeds with the intelligent speed assistance system. And in the yellow, you have the speeds when we turn it off. And you can see that there's a huge shift with the system from the violating area to the compliant area. And if we had a really strict system, we would have cut people off at the speed limit completely. But we had about 10% of leeway in the technology. That explains why there's still quite a lot of people going a bit above the speed limit. And this is the same, that was the urban roads. This is across all the data, all the drivers. And this is the same for the high-speed roads, the 110-kilometre-an-hour motorways. Again, we're cutting out the very high speeds. So a very, very effective system. We asked drivers about their acceptance. Drivers usually say it's good for traffic, not so good for me. Good for traffic is useful, satisfying, is good for my personal goals. They were more negative about that, but they were still somewhat positive, and they were most positive after it was switched off. We actually changed drivers' intention to speed with the technology, and that's quite remarkable. So drivers, after they drove with our system, had less intention to speed. It was a medicine to cure speeding behavior. And we estimated the injury savings based on the kind of accident models, the power model and other models that I've talked about. And these are the reductions that we estimate you will get. This is translating the observed changes in speed into predictions of the casualty accident savings. So 30% savings from the most powerful version of ISA, 12% from the kind of system, the voluntary system that we introduced. And that translates into a 45% savings in fatal crashes. That means if we get everybody in the UK, which is more compliant than Israel, obeying the speed limit, we'll save nearly half the fatalities. You would get more. And then we estimated the savings over time under two scenarios. This was the stricter scenario, and eventually we said sometime in the future everybody would have to use it. And we calculated the costs and benefits based on accident savings, fuel savings, and as you can see, we get a very, very large benefit to cost ratio. That means it justifies the investment, 7.4 to 1. I'm almost at the end. I'm almost at the end.
I'm so sorry.
So, recent reviews, Truls VAR, the most effective driver support system is ISA. The current regulation, review of vehicle regulations in the European Union is coming to the same conclusion. Euro NCAP gives points for ISA, which I guess means that eventually some vehicle manufacturer will actually score it. They haven't yet. And in the future, we can create a dynamic system. So here are my conclusions. Speed management is an overall crucial element in an overall road safety strategy. Speed limits should be set in line with human tolerance for injury. We can get very large savings in fatalities and serious injuries. ISA makes sense. We do need the map, but that's not insuperable. That's just a practical obstacle. And in the future, we'll be able to have a dynamic system. So thank you very much.
Thank you. I'm so sorry.
All right.
Thanks.